Hello everyone, welcome to the Problem Solving Penguarium, where we learn how to solve problems better. Okay, today we're doing a Year 9 standard science question which has quite a bit of maths incorporated into it. So let's get straight into it. Clarify the question. The graph shows that the number of new influenza H1N1 swine flu cases that were recorded between 24th of April and the 3rd of June 2009 in Mexico and Canada. Then we get a graph. So we've got Mexico and Canada. Okay. On the y-axis, it's got the number of new cases. Notice that the scale is not going up evenly, so the increments are not the same. It's doubling every time, so it's doubling. It's an exponential scale, but if we don't know that, that's okay. Down the bottom, however, 27 April, 2nd of May, looks like it's going up every 5 days, which is good, so that's standard. Okay. On which date was the total number of swine flu cases half of what it was on June 1? So clarify what the question is asking. Total number of swine flu cases, or better yet, total number half of June 1. Okay. Now the strategy we're going to use is we're going to find out what happened on June 1 and then work backwards. So we're actually going to be working backwards today. So now I need to work out how many cases we had on June 1 using our graph. Now I'm going to use a ruler here and I'm going to rule up from June 1 and see that it's not the last square but the second last square. Now these, based on the scale which is doubling every time, is going to be, oops, it's going to be an estimation. It's not going to be exactly accurate. Neither is my ruled line. Okay, but that looks like about a quarter, halfway between. It's a quarter of the way between 1024 and 2048. This one, for Mexico, looks like, where's my line gone? Can't see, there it is. A bit dodgy at the moment. This one looks like about halfway. So, we can estimate based on those of being a half and a quarter that the Mexican cases will be 4096 plus halfway between 4096 and 8192, and the jump between them is going to be 4096 because it doubles every time, 4096. And if it doubles every time, I can work out, I can do the addition, I can do the multiplication, but half of 4096 is going to be the next increment down. So it's going to be 4096 plus 2048, which is going to give me, important to do mental arithmetic, guys, so our brains are active and warmed up, as it were, for what we're doing, rather than just spitting it into a calculator and seeing what we get out. So 6144 is the number of cases in Mexico. For Canada, we're going to do the same thing. I can't spell Canada. Canada. Except it's going to be a quarter. Okay, so it's going to be 1024 plus a quarter of 1024, which is actually going to be, if I work my way back down, 256. It's going to be half of it. So half of 1024 is 512, half of 512 is 256. So it's going to be 1024 plus 256. So 10, that's a 0, not a 6. 8, 2, 1. Okay, now here's the question, here's the problem solving bit. Do I need to add these and halve them, or do I keep them separate? Now it's asking us when the total number of cases, the total number is half. However, we need to take it into account for both of them. We need to be essentially halving the numbers of both the Mexican cases and the Canadian cases. Given that it's an exponential scale, it's not going to be the easiest thing to spot, so I'm going to see if we can do this by doing them individually first. So, half of 6144, move over here, so half of 6144, so divided by 2, 6144. So 2 goes into 63, 2 goes into 1, doesn't go. Carry it on. 2 goes into 14, 7, and 2 goes into 4 twice. 3072. So we're looking for 3072. It's not on any of my increments, but I can tell it's between 2048 and 4096. How far? This is how we used our skills before. We estimated that it was halfway between, and we estimated it was a quarter of the way between. So 3072 is, in my estimation, pretty much halfway between. Well, it's exactly halfway between, I think, 2048 and 4096. So I'm looking for something that is halfway between here. I'm going to say this one at this stage. I'm going to highlight that one blue. Okay, now let's do the same with the Canadian cases. I'm going to stop using red pen. So we want half of 1280, 1 you know, doesn't, 6, 4, 6, 4, 0, 640. Now 640 is going to be, where do I think, 512 and 1024 between those two. 640, sorry, is closer to 512 than 1024, and it's actually quite close to it. It's about a fifth if we think about it. So if we just went from 500 to 1,000, that would break it into fifths every 100, and we're just over 100 away from 512. So I'm going to say it's quite close. Now again, remember these are estimates and to an extent guesstimates based on what we can see and our fractional skills. Now, if they were my two options, let's see, does it essentially line up? Okay, so they do sort of line up. And I'm going to say that based on my first estimate of 3072, which was exactly halfway between 2048 and 4096, that estimation is the more accurate of the two. And based on that, I'm going to rule down and see what we run into. Let me draw a line. Okay, so that's what I'm going with. Between the 12th and the 17th, if we broke that into 5 increments, so 13, 14, 15, 16, 17, that is looking 2, 3, 13, 14, 15, 16, 17, that is looking to me to be approximately the 16th. So that's us using it. Checking it, well, checking it is making sure our calculations are correct. Check these. You can check them on the calc again, that's no problem if need be. Okay, but in this case with multiple choices, we're still also checking that if our answer is actually one of the answers given to us, and in this case, it is. Okay, so based on our skills at interpreting the graph, estimating what it is based on our scales as well, because we've concluded that it's the 16th of May was when there was exactly half the cases, or approximately half the cases, than there was on June 1.